right?
Just
And
a
we,
second, because our mic was off.
okay,
Now it's okay.
we're okay. So again, good afternoon, everyone. Let's continue with our 5G KPI. Pablo.
Hi, welcome everyone. I hope we have sufficient people online because we have some presenters from online that, okay, I will check with you when you are here. So I will do a bit introduction on the status of the, okay. So this is the session layout as I presented on Monday and yesterday this morning. So we have now 1 hour and a half to briefly present the status of the white paper work and some ideas on potential continuations or works. Okay? So I will do a brief introduction myself, and then I will leave the other speakers to do their own presentations. And since we have a lot of short presentations, I will suggest to leaving all the Q&A to the end of all the presentations. So we'll have the discussion at the end. So if you have any question, unless it's very urgent, that of course you can. We are always flexible, but in principle, note it down, and we will open up some half an hour for discussion at the end. So I'll try to be quick. Yeah, Markus, please.
Yeah, hello. Sorry, I won't be able to be with you from 3 o'clock on, so maybe we can have my questions at the end of the second session then.
Okay, or I mean, fair enough. If there's some questions about your specific thing, which is be at the very beginning, we can do a small stop.
Yeah. Okay, thank you.
Good. So summarizing the status of the white paper, again, we presented it for the last couple of meetings. The main relevant event is that it's finally published with a DOI, as we've been discussing along the whole week. It has significant amount of authors, as you already know, from a large amount of sources. So we are very happy of the amount of traction that we got so far for writing it, and let's hope we have also traction for following it and get it used. These are the contents of the white paper. So there's I'd say two important contributions. One is the Section 2 QoE definitions and models that we are discussing a bit our definitions later in the next slots. And the other one is mostly around the QoE management framework. Right? And also a very quick summary. I will talk a bit about the management framework now, but highlights of the white paper. So the originating gap that we found was this difficulties of CAPs and CSPs to have a shared view of what was happening in the network that would allow them to jointly optimize in a win-win situation their operations, which also somehow mapped into a gap in the research communities behind both scenarios. So there was also a gap between the multimedia and the networking community to have a common language and some common concepts. And this is one of the contributions, which is having all these definitions and concepts put together. And also on a more operational way, proposing a framework to information exchange between CAPs and CSPs based on something that we call the shared state table. So having a shared view of the situation of the network and the service at the same time. And we wrote how it could be applied to a couple of use cases. So this is just for us to have an idea what this shared state table might look like. So this is kind of a summary of the contributions of the white paper in the operational way, and the guiding thing for the last discussion that we're going to have today, the things that we would like to test. But the idea is that we could share information which is typically on the CAP side, which is the MOS or the video audio interaction quality or the application level statistics, with information which is more typically on the CSP side, which is more about the network status and some rate guidance information, so which is the network resources that are available at any time. So this is kind of where we are, and this is what we want to discuss now, which is our next steps. So first of all, is contributing to ITU. There's the legislation statement that we approved this morning. There's this discussion about the QoE definitions that we will discuss later on. And there might be other contributions from the white paper that we decided that there was no other direct contribution from the white paper to ITU. So it would be kind of delayed we need to think about it more. And especially what we need to do is do some kind of probably be able to try our ideas with any kind of simulation or lab trial that will also be discussed. And the other line, which is this liaison with the telecom infra project that we need to explore and for which we also, formalize a liaison statement. So this is more or less where we are. We are going to discuss later this 1B and 2 items in the, after the coffee break. And now what we are going to do is kind of having a bit of brainstorming held by different people working on the 5G KPI group of potential next steps or ideas that could help us thinking of next steps in the future. So we have 5 presentations for that. So I ask all of you to be brief. I mean, tell what you have to tell, but again, we will have short presentations now, and then we'll have plenty of time for discussion, hopefully, after them, right? So, Marcus, is it okay to use this slide, or you prefer to share it yourself?
Yeah. No, it's perfect. Thank you very much for integrating it. Yeah, also welcome from my side. Unfortunately, I could not come in person, but it works like this. Yeah, we have thought about potential 5G KPI contributions by our study group 14, which is about performance modeling, also performance, quality of experience, quality of service modeling specifically. And what draw our attention and what was really a big discussion also during the development of the white paper was that we identified a couple of control loops. So that means the point where the CSP and the CAP, also the application provider and the communication service provider, have to communicate, should be able to communicate to each other, and not just leave it for the counterpart to find out whether, also the corresponding party like the CAP, to find out themselves. Of course, I mean that has worked a long time. And it's really has been working really well if you think about YouTube, for instance. But we believe that there's more to gain, especially when when you could actually signal that something is not going well, or the operator sees something that the applications don't see yet, or vice versa. And here we have, for instance, one example. This is a typical, what you see on the right-hand side here, a typical resource quality trade-off curve, also where you see a bitrate ladder here. You see a certain minimal bitrate associated to a minimal quality, and a maximal bitrate associated to a maximal quality. So now somehow you travel between these points, and of course, if the resource goes down, the quality goes down. If the resource goes up, it's the other way around, but there's maybe also a limit on the top where we can assume that a further increase of the quality doesn't make any sense anymore, if not for sustainability reasons. So a minimum quality needs to be warranted. So that means we could not drop as far as possible. We could, on the other hand, should not go as high as possible, even if there's bandwidth left. But yeah, maybe this is just the overuse of resources. So and here we have just one of these potential control loops where the CAP and the CSP actually could exchange information. And now it comes, of course, to the question: control loop is always associated with a time scale. That means the question: how quickly can you identify things and how quickly can you react? And there's this common saying that you cannot control faster than you can measure. So the point is, of course, the time resolution the time scales, time intervals are very important here in order to get measures that we can build, because a 5 minutes average will probably not help very much when you're really down to seconds that you need to react. Another example that, so there we have this minimal bitrate, the maximum bitrate, the suitable timescales, but also one item that came up during the discussion was the bandwidth jitter, which is also sometimes used by people in different contexts. We all know that it can be really cause a lot of trouble when the available throughput or bandwidth is going up and down over time. It's not properly defined somewhere. So that could be also a target to get this parameter under control and make it a part of this work. So I just have this one slide in order to open up the discussion, and we will of course happy to get any input or ideas what further could be included. But our main contribution here from question 14 will be to look at the parameters that we need to have these control loops working. And of course, as Pablo mentioned before, also the simulation will give us probably very good insights in order to make this whole concept workable. Thank you.
Thanks, Markus. As I said, now as an exception, because Markus had to go for a while. So on this particular thing, any comments or question from the audience? We can catch up later, but not now so far.
Okay, thanks.
Thanks, Markus. So next presentation is from Luis, but I don't see him connected. So we will jump. I'll try to contact him. We will jump to see it if you are okay to present now.
The last one, it's with AGH. It's a short presentation. Hello. Hello. My name is Saeed, and I'm associated with AGH QE Group. So I would just make that presentation a bit overview of opportunities available for standardizing, like ITUT and ITF forums. I went through one white paper, which is recently developed by Pablo team, 5G KPI. And then I highlighted, it's not like something which is lacking, but it's more opportunities which could be addressed, and it has a potential to be like standardized more in a formal way. So I will go through with, these are the potential area which I basically, after reading that white paper, number one is the Q model, and I'm targeting my field of interest, and which I was doing for 3-4 years. It was low latency streaming. So I was particularly interested that is there any QE model, particularly targeting low latency or ultra low latency, which I didn't get any answer. And there are QE metrics, which is like specifically out of this traditional way and targeting only achieving kind of like low latency streaming, video streaming. So, and then the one thing which surprised me, the subjective method, is that enough to like I can measure or evaluate the video on like over time or changing variation while we are having streaming or live streaming video. So these are potential standardizing kind of topics which is very in, and it has a potential if anybody is that. So particularly in white paper, when I was looking into it, it is targeting traditional Hayes algorithm, number one, which is not particularly like very low latency dominant models. One thing, and there is no the existent models. It is based on segment-based streaming. So we have this new phenomenon of chunk, which we divide the segment further into chunks, 0.2 seconds, 0.5 seconds, different mechanism. And there I didn't found any specific model which is basically addressing the chunk-based streaming or chunk-based mechanism. This is one thing. So this, again, I said, I highlighted, it's not something like criticizing on the white paper, but it's potential future avenues when we can have look into it. This is one thing. And then I will talk about the evaluation data set. Is that like specifically mean by dash stream, or it is like CMAP, which we call it is chunk-based streaming dominant. So we need, we call it standardized benchmark data sets, which specifically address that, and I couldn't found very and this standardized institution, ITUT, they don't have this kind of model which specifically addressing the data set, particularly targeting low latency streaming using chunk-based coding, chunk-based streaming. This is one avenue. So I come up, as I was saying, that I'm continuing my work in that area. So I come up with these standardized existing data set, which is kind of like, it's not benchmark, but people are utilizing it, these established database. And it has a lot of limitation. Like, for example, if we see the Netflix, live Netflix video queue data set, so I just only see the very few technical metrics which I can utilize, like bitrate, buffering, and a lot of technical metrics that which we need to include. We ignore or they didn't work on it. And they have the traditional adaptive streaming mechanism, again, Hayes algorithm, throughput-based, BOLA, buffer-based algorithm. And they basically tested with a limited bandwidth profile. So these are kind of things. For example, if I have a scenario where my algorithm, I'm restricting my bandwidth, like using a conservative approach. So it's not like targeting to that scenario. For example, if I want to restrict my bandwidth to 800 kilobyte, it will not maybe possible in that using that data set. So they have very limited data sets. Then we have Waterloo, which is again a benchmark and a very established data set. They have quite good work. And they have, again, they're focusing on styling, MOS, buffering thing, network abuse. Again, control impairment. So they have very few bandwidth profile, which is not very specific to low latency streaming. ITC dash data set, which is Austria, and this is, I think, one of the foundational data set. And again, they tested the data set with using traditional ABR algorithm. And I'm not sure if they extended that to low latency or ultra low latency, but they are doing some work in that area as well. And dash streamer data set, which again, so I put it here, limitation mean like it is not very targeting, really targeting the low latency or achieving the low latency streaming. So sir.
Yeah. Do any of these data set include a video reference?
Yes. Yeah.
They all do?
Yes. Yeah.
Oh, okay. Great.
I utilize. I'm not sure, quite sure about the other data set, but I utilize the DASH data set from Austria, one of very famous group in the world working on a DASH streaming. But they have all reference videos. Yes. The rest, I'm not quite sure. That's very. We are dealing with reference video. Strip. Thank you. And this is a kind of very foundational model, QV model, which I will just a little bit explain. And I just recently developed it for one of my assignments. And we measure the QV with a reference to video quality. And then I put like there's technical metrics, which is rebuffer, switch rebuffer over time, or how the duration of rebuffering. I have 5, 6, 8, gather 6, 8 matrices, and then latency. And then we give target latency what we to achieve. I think I put 6 seconds by default for my network. So it's QI, which is coming as a model output. And we have here, these parameters coming from my data set, which is average bit rate or bit rate, and then we make it average. We calculate it with one stream and then for complete video as well. So if you have 10-minute video, you can have average bit rate. What average bit rate that video is streamed. So that comes from dash.js log, MPEG dash. And then I have rebuffering duration, rebuffering occurrence of how many times it occurs, switching frequency, latency, which is one element I said, the timing. And these are different weights, which is coming from MOS mean of period score. So it become like that. The A should be greater than 0, which is higher bit rate or video quality, which has directly relation with the QE. So it improves the QE, and the rest of technical factors, interruption, the switching, which we investigated in literature that it has negative impact and it down the overall video quality of experience. And then the MOS, we have 0, or it's not 0, but initial reference video quality in the model. And then we have these weights here with the video rate quality, rebuffering, switching, latency, and these are some random error, which is like outlier. And that give me one overall quality per session, or for entire 10-minute or 12-minute video. So that's all. I think this is one thing to emphasize here, targeting the low latency, to emphasize the importance of acquiring the low latency streaming. This is, I think, one of the hot topic nowadays in streaming domain. So,
Another question. Compared to the ITU standards P1203.3, which has, for example, a recency parameter, is this just kind of a generic proposal for a way of formulating KQI to QoE?
Yeah, but there are many things here. It's like, okay, it's not, as I mentioned, these are all the hot areas. It's full domains. It's not like one specific thing. QE modeling now, it's different domain. People are saying, okay, how you measure the live video quality, or for example, video variation over time. Like streaming is there now. You have, okay, excellent quality, but not necessarily you will, on average, you will have excellent quality. So it is, these are different domains, what your point is, which is not established. As I'm saying, it's very lacking. Like, for example, I didn't found any specific subjective, not subjective, but data set, particularly targeting low latency. Maybe people, they didn't publish, or there's no benchmark, but with ITUT as well, they have very foundational model, and they just define the latency, but they're really not targeting latency. I think this is one.
But if somebody's watching a video, they don't really care what generally, if it's live streaming, they don't really know what the latency is, and they could be watching it for 2 hours, and if something happened an hour ago, it's forgotten.
Yeah, I agree. But if there is a situation when you want to restrict your bandwidth, like you have some aggressive approaches or conservative approaches, then what you will do? Okay, for normal streaming, it is fine, as you're saying. I agree with you. But what you will do when you want to restrict your bandwidth, when you really want to operate maybe 1 Mbit or 800K, there are situations.
I think it handles that situation as well. Okay. That's all I'm saying. Okay.
So,
can you go back to the model?
Sure.
What I don't see here is any audio-video synchronization.
Yes, sir. My work is based on video quality. I didn't. measure the RDF, I think. So this is particularly for my assignment, for my work, which measuring the video quality. Yes.
My suggestion is to include audio.
Clear.
Because video without audio, especially in low streaming, is meaningless.
Clear. Okay.
Right, number one.
Okay.
Number two, on what Eric said, you do need, I'll give you two examples. Switching, right?
Sir.
Switching down is bad. Switching up is good.
Yes, but that is like what the ABR logic, what it select or choose, not we choose.
I understand,
Yes.
but you have a factor that says switching, right?
Yes.
Switching frequency.
Yes.
Typically, models have two factors.
Yes.
How many switching down with a negative?
Yes, sir. And high quality.
How many switching up with a positive?
Yeah. So normally we do average. Like.
So the average could be 0, right? As many ups as downs. So again, try to work out something that definitely includes a differentiator between up and down.
Sure.
And finally, the recency effect usually takes all these factors, video quality, rebuffering,
Sure.
and applies an exponential weighting, giving more weight to the last events, not equal weighting. These are my 2 cents.
Thank you. Thank you so much. And Pablo?
What other? If there's any more short question, and we can keep discussion later. But somebody online? No. Okay. Yeah, I have a quick comment, but we can continue later on that. Well, one is on the recency, but I don't want to discuss too much on that. It depends a bit on what the. So I mean, recency is an effect that is okay if you measure if you ask people at the end. You need to decide whether you want to ask people at the end or not, and what does it mean. So it's it has its own meaning, right? But this is a philosophical discussion, so not so important to other one. And the second is kind of on what Eric says. It's so for streaming itself, the low latency thing is so for content is not so critical in the sense that only live content is important, and basically it's only important if you can compare yourself with other sources of latency, which basically mean that somebody can, screams goal and you are not seeing the goal already. And there's, as far as I know, only one experiment ever published about that in the literature, which was done in CWI like 15 years ago, and I haven't seen any other experiment like that ever. So it's kind of niche, but maybe it should be worth. It's interesting because it's not so easy to test, but they did a clever thing. We can discuss offline. He will come. He was in a meeting, so he will come.
I'm not joined, Pablo.
Thank you, Luis.
Yes.
Okay, so thanks. Are you ready to present like right now, or should we give you a few minutes?
I can make it, but also I can wait a few minutes. So whatever is better for all of you that are there.
Okay, so if you're here, maybe you can present now, and then we keep with the rest of the presenters.
Okay, I guess I can share my screen, right?
Should be able to, yes.
Okay, so let's go for that. So apologies first for the time taking for connecting. I was in, sorry, I will share the other screen. I was in a meeting, I couldn't skip, sorry for that. I would like to comment about the topic of energy consumption, how we could explore that. And basically I prepared two slides. One is related to an activity that we are carrying out in a European project, which is called Exigence, and the other one is some work that we are promoting in ITF, some architectural work. Being ITF, the fora is more network, let's say transport network oriented or network connectivity technologies oriented, but could apply to the entire, let's say, value chain for providing the content, the video content, the streaming. So let me first start with, try to set the pointer. with this slide, with this basically what we are doing in Oxygen project. You have the reference of the project here, so you can basically check. This project is reaching the end. So basically, what we have, the purpose of the project was to work on these three lines. So to being able to measure the amount of energy being consumed for given services. There are use cases for streaming, and basically the notion here would be that we have the content provider that is storing some content that is being distributed later on in the network from an operator or multiple operators, and then consumed by the end user, by the subscriber at home. So the idea is basically to being able to get a measurement of what would be the potentially allocated energy to that specific content. Here we are we are working with different technologies on the storage side or the compute side. We are working with the means of collecting the information from the different caches, for instance. So working with these tools that virtualization provides for collecting the information associated to the compute environment. Similar thing we are doing in the transport network. We are also characterizing and collecting information from what would represent the throughput associated to a given content. Here we could play with the different resolution, of course. This would apply to the compute and to the transport part, and also working on the fact of collecting information from the customer side. This links with another activity, is not represented here, but there is another activity maybe you will know, which is called greening for streaming. They are basically trying to work on the same problem space, so that essentially to understand what could be the consumption of a given service. So once we have the measurement, we have the value. The idea would be to optimize. This optimization could play different, or could be performed from different angles. So optimizing the distribution, optimizing the distribution could be basically trying to identify paths that could be much more efficient in terms of energy consumption, but also even optimize, taking into account the carbon footprint that could be applicable for the generation of this content. I mean, basically understanding what would be the energy mix that feeds the central offices where both the caches are located, but also the different central offices where the different nodes of the transport network are placed. That would be the different angles of optimization. Also playing with the resolution, for instance, or even playing from architectural matters in terms of how to configure, how to arrange, let's say, all the distribution network from the video itself, so the CDN and so. And the last part is about the incentivization. So once we have measured the information, we can also interact with the subscribers on how live interaction or through portals or whatever, for incentivizing them what to do with the consumption that is in principle allocated to them. Of course, here there is all this interplay with the QoS that at the end is the matter of we are discussing today. So basically, what could be that interplay? The customer can sacrifice part of the QoS, maybe because of the quality of experience, maybe because the customer doesn't care at that point in time for the specific content what could be the resolution, or maybe we could basically can live with maybe some reduce, let's say, quality compared with the maximum quality that could be achievable. Today, the systems as are defined try to tend to provide the maximum quality available for all the value chain, let's say, but probably could be the case that it's not necessary. And the idea here is also to explore mechanisms in which the customer, the subscriber, can signal the willingness to receive some quality or another quality. There are different tools that allow some way of doing that nowadays, but the idea will be to generalize that, and also not only even from the direct interaction from the customer with the application, but also even the interaction between the customer, the subscriber, with the network. For instance, exploring mechanisms for subscribing channels, and in that subscription, actually now signaling the fact that the customer could live with let's say non-maximum quality of experience, if that is the case. So this is the work that we are doing in Exigence. As I said, there are a lot of deliverables available, demos, and so demos, including this video streaming, as you can see with these CATS videos and so. So basically, we report with optimize and we try to incentivize this. An important thing, just to a final remark, would be that carbon aware dimension that also could provide some considerations at the point in time or at the point of where from which point, let's say, from which location the content is distributed. This is one work. I will pass quickly to the other work that we are doing, and it could be related with the purposes of BigEG, which is the architectural work that we are proposing in ITF. So maybe this picture is very abstract, but essentially here what we are trying to represent is the fact that we could have different controllers in the network controlling different parts of the infrastructure. As said, because ITF is much more connectivity oriented, here the network elements that could be considered are routers and switches and optical equipment and so. But basically the notion, the concept is applicable to any infrastructure in the value chain. So it could be done the same with servers that are injecting the content and so. And the idea would be so materialize the concepts that we have talked before. So having these triangles would represent kind of software modules. We call them agents in the project, but agent now is a very overloaded word. So it's not agent in the sense of artificial intelligence, it's agent in the sense of a software module that essentially collect the information per domain, and this information is exposed in the upstream, let's say, so other agents that at the end are the one aggregating all the information. We are working on building knowledge graphs so that the decisions later on for optimization, for incentivization, and so could consume that information that is aggregated in this knowledge graph. And the point here is because we are introducing the control part, we could basically also act in the network in the broad sense. So in the servers, in the network elements, the transport elements, and so precisely to satisfy the intent of the customer that could reflect maybe the need of not of going to a more energy efficient service, and also doing this interplay with the quality of the content. We are defining a number of APIs you can see here, and basically this framework is now an adopted framework in ITF Green Working Group, and if everything goes normal, will become an RFC in the future. So basically, this framework would be a standard, and now it would be the moment of start exploring what capabilities we could add here in order to enforce that let's say intents from the customer in terms of the desired aspects of the stream, not only in terms of quality but also energy efficiency. And that's all from my side. And again, apologies for being late to the meeting.
No problem. Thank you, Luis. As I said, we will leave the discussion for the other presentations, but if there's any sort of clarification that is needed, not from the audience, I'd like to have one quick one just for me to understand this better. So could you put an example of how this framework would work, like a very simple one? So who would call it and what would be so who will trigger this to happening and what it would happen in the end? So very, very simple.
This framework allows, we were looking at give me 1 second, at this slide before, the measurement and the optimization part. So essentially here we would have both legs. On one hand, we can provide the observability. We can measure what is the consumption in the network. We can measure what are the different flows. We can have a characterization of the different network elements. Again, the compute part, the transport part, and so we will have this measurement component in this framework, but also we have that other component, which is the action. So once the different, let's say, once the customer express an intent, and based on the observation that we have about the visual energy in the network, we can take some actions. An action, thinking on the content itself, could be to reduce the resolution, for instance. Maybe could be to inject the content from a different cache that this has maybe a better combination of energy mix. Maybe could be to move that traffic to another path that is much more energy efficient, and then trying to remove content or from less efficient paths, and so on and so far. So basically, we have this framework enables to get to get visibility of what is happening in the network, but also to enforce actions in the network.
Thanks, Luis. Karan.
Hello, Luis. Thank you. Thanks, Pablo. Very quick questions. If you go to your previous slide regarding the project, I was very curious about the visibility as you were mentioning. So on the right-hand side, I am assuming it is the mobile edge computing MEC case, right?
Well, that would be any compute environment, let's say, edge or central cloud or whatever. Yeah.
So in that scenario, for example, for the cloud or the edge scenario, have you built some agents that are actually capturing the energy consumption as well? If so, would it be possible for you to point out some of the references, maybe in the chat sometime later, so that we can have a look at it as well, please?
Sure, I will do. There is an open source effort here that is driven by a company called Bull, before was Evident and Atos. So they are providing this open source software so that they basically measure the consumption from the different servers and basically collect that information. So, and that information can be later on integrated on software, on other modules, let's say, upstream, and then integrating everything together. Yeah. I will put some links here. Yeah.
Yeah, thank you so much.
Thank you, Luis. And thank you, Karan, but don't go away because now it's your turn to present.
Sorry, Pablo.
Yeah.
One final remark, just to announce that we intend to do some hackathon in the next ITF in Vienna. We did in Madrid in last July, so there is also some software around, some jam models. I mean, there is real stuff around as well. So I will try to share the information that they have here, but please don't hesitate to contact me if anyone has curiosity to understand better on this. Thank you, and sorry for the delay again.
No problem, Luis. Thanks for the info. Please share the information about the hackathon, sure. And also stop sharing. Yeah. So, Karan, now you have your presentation if you are ready to do it.
Excellent. Is it okay for me to share my slides, please?
It should be, yes.
Okay, thank you.
And Enrique as well. I know Enrique, that you're here.
Yes, Enrique is here as well. So he will jump in as well. So we'll do it together. So hi, everyone. Karan Mitra here, and also Enrique Salza Rossi. We are working at Luled University of Technology, and our main area of research is pervasive and mobile computing. So we're going to talk a little bit about some of the work that we have done recently. When I say recently, approximately 3 to 4 years, more or less, to build objective QE models for several use cases, in particular focusing from the gaming context. And then before that, we have actually worked quite heavily towards building context-aware QE models and causal models, as well as I think it was also discussed in today's session earlier as well. So because the time is short, I will simply cover one use case where we're going to present some of the newly developed objective models, in particular for the mobile cloud games. So as we already know, more or less, and given overall context, is that cloud gaming market is actually rapidly expanding, right? So in that case, what we expect is, based on the latest stats, that approximately 98 million cloud gaming users will be added by the year 2031. And interestingly, what we also see is that 64% of the players are actually playing games on their smartphones on a weekly basis. So playing games on smartphones is actually quite a big domain for monetization, for instance. Further, what we also see is that research projects, some of the research projects that are happening, they note that the revenue for the cloud gaming market is going to be approximately $3.44 billion by the year 2032. So there's a lot of money to be made, specifically from the application developer side, the publishers, as well as from the telecom side as well. So in line with that, it is important, it's imperative for us to actually see from the network side as to how we can provision quality of experience for such services so that end users are happy. At the same time, somehow network operators can actually do to gain some profit out of it as well, right? So keeping in view of that, what we do actually within our group is it basically study quality of experience provisioning in the mobile and pervasive computing. We always assume that the worst case scenarios where the users are actually mobile and then they have the ability to use anything lines while on the move. So when users are actually mobile, and there are a lot of situations pertaining to mobility. For example, intermittent connectivity. For example, it could be network congestion happening, handovers happening all the time, and so on. So we study all these things via real test beds. At the same time, we do a lot of emulations also. Here, what we see also is we just not only study from the networking side, we also study from the cloud side as well. So right now, what we are investigating also is that if we were to deploy immersive systems, immersive services on clouds, how do we actually make clouds application scalable, elastic, cost efficient as well? So our intention is to study this end-to-end chain where the content is actually delivered from the cloud to the end user and also from the end users back to the cloud, while having heterogeneous access networks being the glue that binds everything in together. So when we talk about heterogeneous access networks, we study conditions pertaining to 4G networks, 5G networks, Wi-Fi, as well as any other networking technology. So current research work that we have been doing right now is mobile cloud gaming. We have built some models for virtual reality cloud gaming. Our ongoing activity is also happening as part of the ITOT Study Group 12, in particular for the P.BBQCG project. And we have done a little bit of contribution towards the social XR experiments. But today I'm just going to talk briefly about this mobile cloud gaming use case. So in regarding mobile cloud gaming, we have developed a test bed. Actually, we have developed two test beds at two different campuses. And we have been collaborating quite extensively with InfoVista as well as Ericsson. So this test bed contains certain elements regarding the cloud, for instance. So we can see that PC2 and PC1 are basically hosting the gaming content. And in terms of gaming, what we have studied is from the mobile cloud gaming perspective is the Counter-Strike, CSGO. And router is then connected to the network emulator. So in this network emulator case is something we emulate the network conditions. And I will show you some of the network conditions that we have worked quite hard on for past several years. We have fine-tuned them and have used them in several use cases. So while we have that, we have another computer here that basically captures all the network traffic and then sends this traffic to the smartphone. And in the smartphone, we have an end user who plays the game via a gamepad. And then after individual tests, we have the tablet and the questionnaires are presented to the end users. Henrique, in the last meeting, presented Altruist, the tool that he has built to do all this orchestration to conduct subjective tests in a very seamless manner. So he built a tool called Altruist. It's sort of like a one-stop shop to orchestrate the entire test bed setup for conducting subjective tests. So we are going to release that rather soon. If you need some information about the Altruist, we'll point you towards the paper as well as the source code later on as well. So looking into the network conditions. So these network conditions are derived based on our extensive tests as well as the state-of-the-art studies, in particular with collaboration with InfoVista. As you can see, we have conditions pertaining to the round trip time, and it ranges from between 4 milliseconds to approximately 400 milliseconds or so. Interestingly, we also study the combinations of the packet losses and the round trip time, the random jitter, we simply jitter that we call, as well as the bursty jitter use case. So the combinations of packet losses and round trip time, as well as the random jitter and the bursty jitter, are not extensively studied within the literature itself. So this is something that we have developed, all these conditions, and have conducted a large number of subjective tests. From video side, we consider the resolution full HD, and we have tested using 60 FPS as well as 120 FPS. So in all, this table consists of approximately 37 network conditions. And 2 studies were conducted recently. One study was done back in 2022, if I'm not wrong. Study 2 was conducted in 2023. And we have built some models based on the subjective tests from both these studies, and we have gathered packet traces regarding this as well, and large number of subjective test data. So yeah. Some of the results in very short. I have not included the results for the audio side. On the left-hand side, this side, we have quality of experience measured using the mean opinion score, and then we have this video quality. And we have considered 1 to 5 scale for this. We have 2 data sets, study 1 and study 2, again for both cases as well. Interestingly, as we can see, in case of the RTT values, we are reasonably okay. When I say reasonably okay, we are looking at close to 3 at least, and above 3. So we are around 170 milliseconds or so. RTT does not have a significant impact on the mean opinion score. And if you focus from the video side, it's quite interesting to note that video quality is not impacted even when we have the high RTT values. However, the mean opinion score is affected. And the reason for that was it's not audio and video. It was also about the joystick controller. So when the users were playing game, all that information is also sent to the network, to the cloud as well. So there are some synchronization issues within the map itself. So the decrease in mean opinion score because of the RTT is largely due to the haptic feedback that were received, not just from audio and video. So this is an important distinction for us to look at. Further, as we can also see, hopefully you are able to see it on your screen as well, that the impact of the combination of packet losses and RTT is also quite substantial, even when we have approximately 25 milliseconds. It mentioned 27 and 52 and 102. We have added 2 milliseconds as the baseline end-to-end delay. So in the emulator, we put 25, and then at the end-to-end, it adds 2. So we can see here, the mean opinion score decreases based on, even with low RTT values, with an increase in packet losses here, right? So compared to what we see from the video side, the video moves is a little bit up, even when we have these packet loss rates quite high as well. So 3, let's say if we consider it as a threshold point, we are also reaching close to 8 to 12% packet losses. So the mean opinion score is still high. However, we start to see a decrease in the mean opinion score here. It's also got to do with the interactivity aspect of the game as well. Considering the jitter side, it's quite important, specifically when we are dealing with mobile networks. Per se, we're looking at the jitter of 3, 6, 9, and 12 standard deviation from the mean. And the mean is, we have set to 50 millisecond here. 50 millisecond is, from our side, is a good representative RTT conditions that can cover cloud games that are hosted within Europe. So let's assume if we are in Sweden and we have AWS data center. So we are close to 20 milliseconds of latency between Skellefteå and Luleå and Stockholm. While if we are in Frankfurt, the data center, we are reaching close to 50 milliseconds or so. So we are actually covering a reasonable range if we were to deploy these services on the cloud. So 50 millisecond remains a baseline for us, and we can see with the increase in jitter, we have decrease in the mean opinion score, and it just drops suddenly. It's got to do with the streaming service that is deployed at the end. So we use Steam Link service here, and we saw the similar behavior also for the video as well. As you can see, video actually dropped dramatically. So we are reaching around 1. However, in this case, the mean opinion score is slightly up. We are reaching close to 2 or so. So it's got to do also with that the users are still able to do something when they're controlling the game. So based on all this data, Henrique in particular developed quite many objective models. It started with a very simple model considering the linear regression model. Then we started to fine-tune, go one step at a time, develop polynomial regression models, spline regression models. So I'm presenting these models to you. Henrique, feel free to drop in anytime. And the final model was this non-linear regression model with a large number of coefficients here. So I will not go into individual models. We have different implements. For example, this is motivated from, let's say, ITUT 1072, where we have the high maximum QoE for the session. We have impairments for the RTT, packet loss, jitter, as well as bursty jitter. And individual impairments are in equations 3.1, 3.2, 3.3, and 3.4. Just moving forward a bit, so we present to you the model coefficients here. So we would strongly encourage you to actually go and test these out as well and give us your valuable feedback. In terms of models performance, we were pleasantly surprised to see that linear regression model actually worked quite well as well, with a reasonably good R-squared value of 0.74. And the mean absolute error for the tests for both the studies were basically 0.369. Well, not too bad. However, it's failed when the conditions were pertaining to jitter and the combination of packet losses, as well as RTT, of course, because of the non-linearities in that case. Spline regression worked quite well with the mean absolute error of 0.186 and the R-squared value of 0.93, and non-linear regression with the mean absolute error of 0.235. And so these three models were actually are some of the ones that I'm presenting here. There's also another one with polynomial regression. So so these are the basic results from our side. What we have presented right now is our ongoing work, where we are trying to build these objective models for mobile cloud gaming. We are doing a regular subjective tests. We continue to do so as well. We try to study stochastic network conditions that are prevalent in heterogeneous access network conditions. We have built similar objective models for virtual reality cloud gaming. And currently, we are being part of this P.BBQCG activity. We're trying to help build objective models within the ITUT study group 12, quotient 14 as well. I'm happy to say that the set of realistic network conditions that we have come up with in InfoVista have been used by other labs as well, and we are hoping that these test conditions could be used by several other labs and also become part of the standardization activities. So, for instance, recently it was used in the ITUT G.1051, the conditions in table 2.2 on page 22. And we have presented several ITT contributions in this area of cloud gaming. Our intention is to contribute towards VQEG activities by trying to understand and learn and propose network conditions with all of you and share our expertise. At the same time, we continue to develop some standardization activities within the study group. So thank you very much. So these are some of the references here. So if you have any questions, feel free to ask me or Henrique. Enrique would be the better person to actually answer the questions. So, thank you.
Thank you. There is a question, but the microphone is going. So.
Hi, very nice presentation. I know how difficult running subjective tests on interactive services is, but I have a kind of a notational quibble with the term cloud gaming, because
Yes.
there could be remote. You're assuming remote rendering, but there
That's
could be
correct.
hybrid rendering. There could be local rendering, and the network requirements for local and hybrid rendering are very, very different from fully remote rendering. And I know that the hybrid and local rendering are kind of uncommon today, but over time, if quote-unquote cloud gaming gets popular, then I think in order to save bandwidth and improve performance, there'll be more and more of the rendering done locally. So I would suggest you kind of clarify that in your terminology.
I completely agree with you. And Henrik and I have been breaking our heads regarding this terminology ourselves, to be honest.
Karim also does not like it. The fact is the stakeholders like Microsoft, Ericsson, and many other big companies, they start to use the term cloud gaming quite often. And that's why I also decided to use it too. But with the awareness that it might confuse people still. So I understand, yeah.
So you will notice that in some of our papers, if you're interested to read, we have started to use the term cloud streamed games. Actually, it could be streamed via any device, technically, right? So as long as it's streamed over network, this is precisely what we are studying. So, but we're also bringing in with the new research elements from the cloud itself as to what happens if you were to deploy these streaming services on the clouds. What happens if the CPU utilization, GPU utilization increases? What is the impact of memory footprint on these services as well? So this is something that we are also studying right now. So we have tried to keep it a bit more general, but I completely agree with you. I'm with you on this terminology.
Sorry, we cannot hear you.
There's also a problem with using the word streaming in this context. It's more like video conferencing, WebRTC technology. It's because it's unreliable delivery. It's not HTTP streaming, generally. So that should be clarified as well.
That's true. Yes. Thank you for the comment. Yes. Completely agree.
Thanks, Karen and Enrique, for the presentation, also for showing the environment that might be useful probably in the follow-up discussions later, and also for showing the use case and the results. I have a couple of general questions, but I will keep them for after David's presentation, if you are ready. And then I have a couple of ideas that we might be able to discuss in the final 20 minutes or so. So I don't know, David, if you're ready to...
Oh, I am.
To present your part?
Yeah, sure. Find that. I will write it in right there. Okay. Sorry. I'll be right back.
Okay. He's probably fixing the permissions. Sometimes you need to go and close the application and open it again. So let's hope he's back soon.
All right, I have to reapply the settings for the sharing. Now I'm back.
Okay, David, go on.
Trying here. So I will run it in this mode to take notes as well. So I'm going to give a short overview of an update I'm going to propose for the next ITU meeting that's coming in a couple of weeks. And we have a proposal for an extension of an existing standard. So the standards that we have we're talking about is the P.1204.1, which is actually a fairly new recommendation. It was consented last year. But yeah, it's very simple. I will show you. I'm sure that not everyone is fully aware of what the standard contains. So I'll start with a short description before I go into the edits as well. The P.1204.1 is a very simple video quality model. It's made to assess video streaming over encrypted networks and other services where you don't know so much about the service, but you maybe can measure bitrate and know a little bit about the codec. So this is what we call a parametric model, where you take some media parameters, like the list here. This is from the standard, like codec, bitrate, frame rate, and media resolution, and try to assess the video quality based on that. This is, of course, a very limited model, but sometimes you need something simple to do and give anything. One of the core missing things here that we found out, or that anyone who's tried to create such a model has found out, is that you don't know anything about the video content that you're trying to assess with these basic metrics. If you can quickly understand that if you have a difficult content to encode or a simple content, the model will give the same result for 200 kilobits, but the actual experience might differ quite a lot. So we have a very simple proposal here, that we need an update on this model. The base model can stay as it is, but we need an extension that can take in some complexity metric, we call it alpha here, from either the streamer or a client, or some analysis tool in the processing chain, either from the encoding side or the client side, decoding side, that can tell us something about the content complexity. We have a couple of different ways of calculating this alpha, but it essentially changes the bitrate quality impact equation to try to accommodate this. And this is an example from just one video that we ran a couple of experiments on. The MOS ground truth here is P.1204.4, which is a full reference model similar to BMAP, for example. That's an ITU recommendation that we're using, which is has really high good performance on quality estimation. So it's feasible to use it as a ground truth for these more simpler models. Anyway, in this figure, you can see quite easily that the ground truth samples that we have in the gray boxes there don't really match the blue line, the dashed line, so well, which is the baseline model. Due to this, this nature video has quite high complexity. It needs a lot of bits to render all the grass and everything that's in that. So by using then this alpha metric, we can try to adjust the blue curve so it matches the green curve, which gives much better correlation to the actual quality experience of this video stream. And the suggested update to the equations, it looks very simple. We add this alpha in this is the quantization component in this parametric model. You can look it up in the recommendation if you want more information. But this whole model is actually very simple, so it's not much more than this. And by adjusting this alpha, you can sort of shift that curve in a couple of directions, and to get it to adhere more to the different content complexities. And what does this give us then? Well, if you look at the baseline on the data set that we have done, pretty big 70,000 sample data set where we've assessed it, the baseline 1204 has a pretty high RMSE and low correlation to the actual MOS. But then by using this, either like what we call it Oracle trained alpha value, which is the best you can do with this parameter, or an estimated alpha based on on some parameters that you can obtain from the videos themselves. You can get these better values. And this is how to estimate the alpha. That's actually still up for debate. In the full contribution that I just submitted to ITU, there are 2 ways of doing it, and there's really no correct way of doing it. We're talking about having some kind of metric that you can create from maybe SITI values or something from that the encoder can deliver in terms of, or an encoder could deliver in terms of motion vector statistics or something like that, that you can get from a reference encoding or something. Yeah, so this is sort of still up in the air. We could probably do better than I've done in the first one, but yeah, so this hopefully can, especially in the light of the 5G KPI, where we're talking about which metrics to transmit between client and servers and so on. I think this could be a good candidate for a model that can be used by networks, for example, to predict how clients will behave when you change their the allotted bit rate for a video stream, for example. And that's basically it. I will try to, the recommendation itself is, of course, behind ITU doors, let's say, but I plan to do an open contribution on this to some kind of paper as well.
Thank you, David.
If we get the recommendation, of course, that will be open. So.
Thanks. There's a question here, so.
Hi, David. How are you doing? Eric here.
Eric.
So given a codec and a screen size, there can still be variation, and given scene, there can still be variation in the bit rate based on the amount of computing resources that the CAP applies to that encoding. For example, if it's unpopular, it's going to spend less resources than popular content. So how do you account for that?
Yeah, I mean, that depends on how you create this alpha value for a certain clip. You could essentially have it, it could be captured by this. If you for example, have a YouTube clip that is very popular, as you say, they have spent more time for it. It would actually just switch that alpha value slightly for that content. So yeah, you can use it for that as well. It sort of takes care of a little bit of the problems that we had for evaluating these very simple models.
Hi, I have just a question. Can you please come back to the equation? Because I don't see how the alpha is changing anything. Because if you rewrite the equation, the alpha is changing just to a change in the value of A, or I'm missing something.
Yeah, the alpha value it doesn't exist in the algorithm, right, as it is now. So we introduced that there.
Yes, but the thing is that if you use the logarithm, so I can change the multiplication to the sum, and then I can rewrite this equation to exactly the same. That the only difference is that I have A plus B logarithm of alpha plus B logarithm of BR. And then I can name A plus B logarithm of alpha as a new A prime. So nothing changed.
Yeah, sure. I mean, in principle, yes. Or you're correct. This quantization parameter is also used in a logarithm later, so it will be a slightly more complex result. But in essence, what you're doing there is just because this A value is a constant that's obtained based on codec, essentially. So for different codecs, you have different coefficients there.
Okay,
so what you're doing is
okay.
Yeah.
Okay, I understand. So you are not estimating A, B, C, D. You are only changing the alpha.
Yeah, exactly.
Okay.
So
now
ABCD is from the standard. Yeah.
Okay. So thanks, David and Lucian. So we have 15 minutes before the break. I have two a bit more generic questions. So the first one is about energy. So maybe for Luis, but probably Yanni can catch up as well because he also has a lot of experience on the topic. So how should we incorporate, so which is like the low hanging fruit? So which is like the first order of magnitude idea that we should incorporate, thinking about energy consumption in our services? And more specifically, is there any information between CAPS and CSPs or between the different stakeholders that could be somehow exchanged so that the overall optimization of energy consumption can be improved? So I know it's a bit generic, but that's, in short, is we don't think too much about energy. We need to start by something. So where should we start from? I don't know if there should be a microphone, for Gianni. And also, Luis, you can jump in if you want as well, but maybe Giannis want to start.
Yeah, let me see the discussion by saying that probably at ICIP there will be a paper that we publish. I think it's been accepted, but I don't want to be overconfident exactly on this topic, right? And obviously, energy, what I think, especially when I hear about regulators and governments, etc., they care about end-to-end. Understanding that some of the energy is spent on a user's device, some of it is spent on the radio tower backend, and some of it is in the data center. So the way I see it, end-to-end energy is what matters and probably should be shown, which means that every party that knows exactly their components should say, okay, so that that video, is 1 gram of CO2 when it comes to the tower and, 2 grams when it comes to the data center and whatever else. So that's my high level. The challenge here is that when you say I'm going to measure and then optimize for it, right? We should be optimizing the sum, as far as I'm concerned. But that can be done in maybe the optimal point would be that, you have to do more on the data center. For example, go to a slower setting of an encoder, because by going to a slower setting on the encoder, you're going to take a one-time hit to reduce the bit rate, which means that N transmissions over the antenna tower will cost less, right? But that really is shifting a little bit like the burden from one to the other. So there must be, in my opinion, some kind of protocol between the two, so that, because the easiest push would be, in order for me to reduce my energy footprint, why don't you spend more energy, which is at the same time both costly and actually could not be overall the optimal solution, right? But high level, we should all understand that what are the factors to determine that end-to-end energy, and that's part of the paper that I'm talking about that's going to be presented at ICIP. The dominant factor is the popularity of a video, right? Because the multiplicative factor because it's one thing to say how much watching one video is, but at the end of the day, it is the aggregate that we care about, like we do for the system QE and all the other factors that are in the white paper. And therefore, we need to understand that the popularity of the video is the most dominant factor when it comes to the energy footprint, let's say, to the globe, right? And that's why the natural strategy that Meta, YouTube and everybody else has been publicly talking about is this differentiation and different treatment for very popular videos versus less popular videos, right? And that makes total sense if you think about it, because the very, very popular video is the one where the one-time hit on the processing side makes much more impact, because that is multiplied by, say, 1 million times views. But I think we should all at least make some kind of a basic model available to the other party, right? So essentially, the CAPS should say, okay, the energy is X joules per bit. I'm just making up a number here, right? Because then when the decision comes, where should you be spending more power, you have at least some proxy of what would be the cost, and therefore this taken into account. Similarly, the CAPS, the CSPs should know that, to request, this service provider to save 10% additional bits would actually mean so much more CO2 on the data center to spend so many more cycles? Is it really worth it? So by at least us having this very simple model of what does it take to, how much energy it takes to pre-process a video and transfer it to the antenna versus how much it takes to take from the antenna to the user is the starting point. This is just to seed the discussion. And yes, Luis, I think it's a very important topic. And it's important, and I think it's going to gain importance because energy is becoming sort of the next frontier in everything we do, not only in video streaming, but, you know, training, data centers, AI, LLMs, et cetera, et cetera. So we need to be very, very cognizant of that.
Yannick, I have just a short question to what you said. Do you think the metric should be CO2 or energy? Like if that doesn't make any sense to think about like that for this data center we can ask about a better compression. Or, no, it doesn't make. Yeah.
In my opinion, it should be energy rather than CO2 because you don't know what is the underlying technology that created that. Even though there is nowadays there is a standard exchange factor, which is the blend of all types of you know, power plants into energy. But fundamentally, energy is what matters, joules.
Yeah, I mean, in terms of, you could think about, you know, energy and the time, meaning that the cost of energy or the CO2 of energy might depend globally on the moment because of the, you know, generation, which is somehow also reflected in the price as well. So, you know, but it will probably won't be like a constant factor for anyone operating at a given moment of time, given a number of constraints. There are also, okay, yeah, Luis, please go on.
Yes, just to comment on this point. Yeah, also we need to take into account that there are different time scales. So probably getting the information from the energy mix for the different central offices and so could not be as let's say real time as could be the energy consumption in the devices or the compute nodes or CDN caches or so. So probably we need to play. I mean, maybe we need to collect even both. But noting that there will be different time scales and maybe some further correlation is required later on. So yeah, just to comment on that. And for sure, energy is what we can collect, let's say, more or less real time, and we can take decisions on that, short-term decisions, let's say. But maybe for the energy mix, we need to extrapolate consumptions, and as you said, it's very dependent. It's seasonal dependent, is dependent from night to night or whatever. So yeah, there will be different implications. Both are relevant, but what is in our hands probably first is to collect the energy measurement.
And just to add, since we have Matthias here, and we heard yesterday that the new SIFT is now an open call where different complexity operating points or even different standards, you want to call them, can be there. Say, the next coding standard to have the energy mode and the expensive mode means automatically that when you are, say, the cap and you have this opportunity, you can evaluate, right? Should I use the very energy efficient mode? Should I use the middle mode? And that would be yet another parameter in this optimization that can play a big role. So just to, you know, oversimplify things, right? Even if you know that there is this super expensive 100 times more, if there is an 100 times more expensive way of encoding that will save you 10% bits, and you know that this will be streamed 1 billion times, you are going to obviously leverage it, right? But the question is, how many videos have a billion videos? And then you realize that the opportunity will be restricted on a very small but extremely popular content. Could be, for example, the Olympics, right? Could be a stream that is really viewed either real time or on demand, you know, multiple billions of times. And therefore, you automatically help those who create the next standard ahead of time have an idea of where that can be leveraged and how. In my opinion, there is a direct fit of a codec that will have these different operating points, and so that, you know, even older standards, right? Because encoding is not you have knobs anyways today. It's not deterministic. People are leveraging it, but if you design a standard having that into account at the design phase, I think that lever can be much more powerful. That's really my hope.
Thanks. a couple of small extra additions to that. One is that, energy consumption has two totally different views. One is the kind of the data center infrastructure energy consumption. Well, the big numbers make sense because this is where the CO2 and the, and the money and everything is. And the other one is that the device consumption, which is also important, mostly because of QoE. So basically because of battery duration, which is a QoE factor that we don't take too much into account, but it's very relevant. And of course, the scales of consumption are totally different and the implications are totally different. So probably they must be handled differently, but both things are important for different reasons. Yeah. And the other thing is that there are a lot of, fixed costs and also heterogeneity of the contribution of the different factors to that. So for instance, in the device consumption, the screen takes a huge percent of the consumption. So you can do whatever you want in the coding, but the screen will win. Or in the mobile networks, for instance, there's a fixed, all the baseband thing is basically fixed cost. Only the radio transmission depends on the, the device and the number of devices. So there are a lot of things which are non-linear and a lot of non-trivial things. So this kind of joules per bit or whatever is something that's definitely cannot be thought of a linear curve or anything simple. So good. We have. Yeah, sure.
Luis, because you showed that you would like to give, as far as I understood, users opportunity to decrease the quality because they don't need this quality. I wondering, do you know any statistics about I guess that YouTube, we all have this opportunity. In theory, it's not very difficult to get and to decrease the quality if you don't need it. But do you know if users ever use it, or what are the situation or something like that?
No, actually, no. We don't have real statistics on that. So it's more linking the idea with the idea of incentivization so that we could, let's say, motivate the user to do so because maybe they can have better plans or whatever, these kind of things. Are these kind of ideas. We do not have a clear picture about how many users will be willing to do, let's say, without any kind of incentive.
Yeah, and Narciso.
Just a minor consideration of everything you have discussed is that I was thinking that there are many items, not many, at least a large set of items that are included in the overall evaluation of QoE. We begin with rate distortion, but the rate distortion is mainly defined in one point, that is the coder, and can be applied elsewhere. But for example, when we go to latency, latency appears in different places with different origins, with different characteristics, but at the end, aggregating the different energy latency items, we obtain an overall latency that can be considered for QoE. But I think that, I consider that in the case of energy, each one of the energy reductions or increases has a different influence in the QoE. So it's not only a simple addition of all the reductions or increases of energy, but also in the influence on QoE. Because at the end, of course, as for example, Yanis has said, energy is the new frontier. We need to decrease energy, but the way in which energy is decreased in the whole chain from the source to the consumption can be done in different ways, and these different ways could affect in a different situation the experience, the perception, as Camille said before, that was the final word, the perception of the user. And as far as I know, I haven't seen any study of the different influence of energy reduction or not. For example, we have considered here the encoding, the data center, the transmission, the radio. The radio, for example, there is a strong influence depending on the band or depending on the generation that we are considering, the screen. And I think that there is more research required just to be able to identify and to obtain an overall model that in this case will be more complex than the rate distortion, the latency, or other models that we have used before.
Thanks. So I'll finish this and open another thing, just opening it because we are going to the break. But there's been a couple of papers, this at Quomex in the last 2-3 years with some studies about that. There was a good one in Ghent 2 years ago for the streaming use case, which was quite decent. But again, not a lot of research. So yeah, it's definitely needed. So I think it's been a good discussion on energy. Probably I don't know if the first one, but one of the first ones in Vico. Hopefully not the last one. There was another topic that now we're going to the break, but maybe we will catch up later together with the simulation part, which is about which kind of models do we need, not to monitor the quality, but to optimize it, right? Which is somehow a bit tricky because what we have now, so we have very complex and kind of fine-tuned models which work very well, like 1244 is .3 is a great example of that. But sometimes you don't have this information, or you are like optimizing for a new use case, like what Siad said. So that's okay. But if I want to optimize for low latency bitrate or low latency streaming, which was not considered in the development of the model, I need something else. So I need to make it, up, right? So I tend to think that for the purpose of exchanging information between CAPs and CSPs, we should find out some like a very, basic core number of parameters which makes sense to exchange somehow. So like, how can we describe as much as possible about the situation with as less possible parameters, right? So that everyone can more or less make the best use of that. And it's nice because there's been a lot of ideas around that indirectly. So there was some simple models in Siad's presentation. There were some models in Karen's presentation. There were some simplified models in David's presentation. So I think that it's nice that we are all around there, no? And there's something that have not been presented but have been mentioned, like again P1204.4 or .3 or whatever. Sorry about the numbers. Alex, you need to do something with that. It's totally impossible to remember the numbers of the standards. Yeah. I never know what to talk about. But just for us to think about it, because probably one of the first things that we need to do when we do the first proof of concept of the CAP CSP exchange, and let's discuss later about that, is to identify like the quickest win. So which would be like the best possible, or the most general, or whatever, or the simplest possible thing to exchange that could create the best benefit. And I think this is an interesting way of thinking that we could leverage later, and also thinking about which use cases might be more relevant. So I will not open it for discussion again because it's break time. So we will resume at 4 p.m. if we are on time, yeah. So we will resume at 4 p.m. For the ones who are online, we already covered the liaison statements this morning. So we will mention them briefly for the ones who didn't attend this morning, to check that you are okay with that. But we will discuss first, hopefully, briefly up to some point on the definitions, and then a bit longer on the next steps in terms of simulations or experiments. So we'll be back at 4 p.m. local time, and whatever your local time is. Thank you. Okay, we are back online and ready to start the last session. Let me hopefully be able to share my screen. Oh no, I need to join. I'm not in the meeting. Oh. Let me give me a minute. Oh, here. Okay. Let me share my screen. It should be not this one. Okay. So we'll change a bit the order. We'll finalize or quickly review the relation statements for the ones who were not present before, and then we'll go to the discussions. If you're okay, Yanni? Okay. So for the ones who just connected for the meeting this afternoon, we are going to send two relation statements, one to ITUT and another one to the Telecom Infra project, describing what we have been done in the white paper. And that the white paper is published basically. So we already formally approved them this morning in the VCOG meeting, but for the benefit of the ones who were not able to attend, I will quickly go through them, and if there's any comments, please, it's the last call to make it. So this one's shown in the screen. I will go to the top. This is the one to ITUT. For information to the study groups 12, 13, and 21. 12 is QoS, QoE, and performance, the ones that we cooperate with more. 13 is more about architectures, and that could be interested from the perspective of the CAP CSP management framework. And 21 is the basically media coding one, so the one who works with video coding. We have some people from 21 here as well. So they could be interested. And this is the content. So we are informing of the publication of the white paper. They can find it here. A very, very short description on the white paper purpose. We expect that it will be useful to the ITUT to develop new standards for CAP and CSP information exchange. It includes some work on QoE definitions, which will be used to prepare a specific contribution to question 2, which is what we are going to discuss in 2 minutes. And next steps, we plan to further validate the proposed concepts through tests, simulations, and proof of concept activities, and welcomes continued exchange with ITUT on this topic, which is what we are going to discuss after the definitions part. Still, what we agreed this morning is that this information is probably enough for now, and when we have more details on our experiments, we will share them with ITUT. The second relation statement is to be sent to the Telecom Infra project. Well, we've presented about the Telecom Infra project a couple of times, so I won't spend much time on that today. Well, maybe Francois can mention a bit. Let me, Francois, go through it a bit, and then you can probably complement what I'm saying. So we are giving the same information to them that what we do to ITU. We expect that it may be useful to TIP QoE management group, which is a group that they recently created to basically design common QoE metrics and exchange mechanisms between CAPs and CSPs, which is actually the purpose of the white paper. So we really think it could be useful. And we communicate that we are going to do some validations. We, in principle, are not adding any additional information to this relation statement. And yeah, Francois, please. You're muted, sorry.
Thank you, Pablo. Thanks for doing this. I think this liaison statement is good. My only comment is TIP is most likely going to try to do as well testing, as the members of TIP includes many service providers. So I wonder if the next step, your last paragraph, I'm not sure if we should rephrase it in a way that, because we're saying VQueg will do validation, but I suspect the tip will also do. So I wonder if it can be reframed in if we want to collaborate together, or so on the testing. That's maybe some thoughts I have.
Thanks. I didn't propose anything in particular because my impression is that we don't have enough information about what they're doing to really understand what kind of collaboration we could have. So this was a bit like not much compromising. We could maybe add some other sentence to ask about this information, like or maybe it's okay. I mean, I will go to the meeting next week, so we'll get information anyway.
Okay, I think I just wanted to flag that. Maybe that's good. Now it's a bit neutral here, so maybe that's okay. They will probably say, of course we will do some testing, but that's fine. Maybe it's okay after all.
Oh, thanks. Yeah, I didn't want to kind of open a debate on how to cooperate with them without actually knowing what we can do ourselves and what they want to do. So, but maybe for the future we could think about closer collaboration. So let's open this, but I wasn't confident enough to propose something more specific than that.
Okay.
Right now.
No. Let's keep it neutral. I was just saying that they might feel that, we're planning to do that as well, and why do you want to do that yourself? But I think the way it's written, it's okay. I think the tone is right.
Great, thank you. So if there's no more comment, we will be sent after the meeting. Yanni, we can discuss on actually how to send the email or whatever. Great. So let's go for the first discussion topic, or joint work topic, right? So, which is preparing a contribution about QoE-related definitions. So, yeah, I see a lot of people involved. I see Marcus is online, which is good. I see Alex is here, which is good as well. So we have probably everyone ready to discuss. So as I mentioned, I think it was in the last plenary meeting, there was an initiative in ITU to reopen the definition of quality of experience for a number of reasons. Basically, they found it not actionable enough for their purposes. And there was also a lot of different QoE-related definitions, not exactly, or QoS to QoE-related definitions, not exactly used consistently across all the documents in ITU. So they were trying to reorganize that. They made a proposal that was not very well received, I would say, in the last plenary meeting in September. So we had a meeting with them in February. We were invited to one of the internal meetings of question 2 last February. We presented a couple of documents. So there was a contribution by Marcus and Alex, which was basically 5 theses or 5 reasons why we should keep quality of experience defined as the degree of delight or annoyance of using a service, so keeping the core of the definition, which is today coming from the QualiNet word. And there was a second contribution, which was basically our QoE chapter, or definition chapter from the white paper. It was kind of an informal contribution for that interim meeting. So we were asked by the question 2 rapporteur to do a formal contribution for the next plenary meeting in June. And I think that we could be a bit farther than these preliminary things and propose something a bit more specific. So this is what I have drafted, and I would like to discuss a couple of things, and some of them I can fix online, and other I will note down and fix them offline. So first one is who wants to join as contact to the contribution. So names it doesn't need to be the first one, but please, if you want to be, listed as part of this, let me know. So, yeah, that's it. So I have some obvious names to put, but anyway. So I was thinking on a contribution in the following shape, and I've prepared the document in a way which is hopefully useful for today. I will completely uncirculate through the authors before the deadline, which is soon, but I don't know exactly.
27th, as far as I know.
27th, right? So we have
in a week.
We have a few days to finalize it. So the introduction, I was basically going to mention a bit the list of contributions that have been done about the new QE definitions. I don't know, Marcus and Alex, if you want to directly contribute the document that you sent in the last meeting as contribution to the, as like independent contribution to this ITU meeting or not, or just to, I mean, whatever you want, or if you have an idea. So the 5 theses, just to mention it here, to include it here, or to not do anything about it, just.
Yeah, I mean the document is 2 or 3 pages long, so maybe it's a bit long. Also maybe it has to be condensed. But on the other hand, what we basically did, I mean, calling it 5 theses, that was a bit linking back to Martin Luther. He had 95, we have only 5, but still there are theses where we just wanted to put our foot on the ground and say, okay, it's not going to work as you have planned. So basically, it was a pure defendance of the term quality of delight, degree of delight or annoyance, and we made some items clear that we have to become a bit more specific. That we, for instance, have to include the context in which we are working, and I mean this links very nicely also to the actually part that is in the VQuac in the 5G KPI document with 3 new definitions, which are just more specific than the general one is that somehow had to fit everything, but it could not do it because I mean if you want to do it for pure understanding, or whether you want to use it for provisioning, whether you want to use it for monitoring, there can be different things. And that was one of the observations that we also had, that, I mean, if you look at the area of quality of service, of course, it's a big notion, but you have tons of quality of service parameters, yeah. But in the quality of experience domain, it has been always somehow going around the moss, yeah. And it's not necessarily the only thing to look at. So basically, I mean, Alex, what do you think? Should we maybe try to condense this part and then also focus on the proposal that we do? Because we have actually a proposal that we exchange. There's a note in the QE definition which says something about that this is still a working definition. There's work going on, and I mean this is dating back to 2013. So we have been using it so heavily during the time, and I think this is also a reason why people get in doubt, because they say, okay, if this is still floating, that we just propose now to remove this note and replace it by a note that is saying basically that it is a quality of, also we cannot put it as a part of the definition, but we can put it as an explanation that it's an appreciation based quantification, and that it is highly context and content dependent. So basically to clarify that QE is much more than one single thing that is so abstract that people have difficulties to use it.
Yeah, thanks.
So these are basically our plans.
So Alex, any?
Yeah, what I'm not so clear about is really, do we want to actually write, I mean, it's also, I mean, I'm speaking aloud with Marcus, so we actually didn't talk about this before. Marcus, I don't know, you don't see me, I'm behind the column in the room.
No problem.
Yeah, I'm wondering, I mean, can we modify it in such a way that we would be inserting it here into this contribution and then basically become co-authors here, or do we want to have it separate? I think the idea would, of course, be to converge somehow, right? I mean, the key issue I think that I'm still having is that this observation number 2, right?
I mean, it's a valid observation that you have there, Pablo, of course, but yeah, but there's also 3, right? So yeah, what do we do? I mean, we modify the 1 and 2 and expand it and then provide additional definitions. Is that the consensus we're kind of having? That would be the way forward that I would like, right? So I think it is good to not change the base definition completely and yeah.
Okay, so maybe let me go through how I have structured this contribution, and then we go back, because maybe we should write.
Yeah, maybe that's better. We cannot find this somewhere, can we?
Oh, probably not.
Yeah, no worries, no worries. I was trying to find it, but yeah, no worries.
No, I shared it with Marcus to prepare it, but I haven't uploaded. Okay, sorry about that. Yeah, so basically, I have put. Okay. Sorry. So, roughly speaking, I will try to summarize the what's in the white paper. I will copy the white paper at the end. I mean, it's the whole chapter, but basically, these are the 3 main observations derived from the white paper, and then we can elaborate on that. So the term is not used consistently in the industry. The definition is not sufficiently operational. We can elaborate on that. And the lighter annoying definition basically has gained significant traction. So what we propose in the white paper is that the core of the definition should be maintained. In white paper, we assume that it's the Qualinet complete definition, but from our perspective, the differences between Qualinet and ITUT definitions are not so relevant. But this is my understanding. Because there was a comment from the question to rapporteur that we are using Qualinet definition and not ITU definition in our white paper. I don't think there's a strong difference because they are all the lighter annoyance based, but whatever. And then like item number 2, this is I think what we agreed for the white paper. So if I'm wrong, that's fine. But so
sorry, just to interrupt here.
Sure.
I think one of the challenges, the reason why there's only the short version in the ITUT standard is probably because they have very strict formatting requirements for the definition. So therefore, they have only taken the first part. And then everything that is explanatory and so that is probably to have to go into a note. So therefore we have these different versions of because it's only the first sentence that is part of the ITUT definition and the rest is omitted.
Yeah, it's recommended to have a definition that is even one sentence, directly in the ITUT standard.
Okay.
Exactly.
And a comment here, Francois?
When you say the core of the QE definition should be maintained, you mean the core, the ITU definition or the Qualinet definition or the VQuag paper definition?
It's the ITUT, I would say. Also the core is degree of delight or annoyance. That is the core.
I want to specify it so it's clear.
Okay. Yeah, so it's the core of the ITUT QE definition, which is basically the same core or basics of the VQuag. I mean, of the Qualinet that we are using in our VQuag white paper because we are not redefining it. So the second proposal is that we need a new term to describe a more restricted, more operational vision of the QoE, which is the effect of the manipulation of a few system conditions on the lighter annoyance. This is user-reported QoE. This is on the third contribution or item from the white paper is that we grouped the different QoE-related terms in the literature into significant categories, which use this layered model. And item 4, for each layer, we selected a QoE-related term from the literature or coined one if needed and provided a proper definition. So this is what we did in the white paper as a summary, and the details can be found in the white paper, and we are going to plan to copy the appropriate chapter in the annex, I mean, in this, at the end of this document so that people don't even need to go to the white paper if they don't want to, right? So this, considering this, we have, I would like to discuss two proposals. And maybe we can go first to the proposals and then go back to the justification if you're okay with that. First one is to modify the definition of QoE. This is basically Marcus' proposal, but summarizing what Marcus already mentioned. And then to add new definitions extracted from our QoE document. And for that, I have this proposal that we can now discuss about the QoE definition. For the addition of the new QoE definitions, what I have done is just copy all the definitions that we have here, but I'm not proposing adding all of them. I just copy them here so that now we discuss which one of them we should add and which one of them should not. And when I delete the ones that we don't want to add, right? That's kind of overall my plan with this draft. And sorry for not sharing the draft in the repository. So I think if you're okay with that, I think we can start discussing about the specific contributions or proposals, because this is what we really want to be changed in the recommendations, and then we can go back a bit to the rationale and the justification. Okay, so maybe Marcus, you can explain a bit this proposal number one, so modification of the QoE definition, and we can discuss if we agree on that.
Mm-hmm. So this is actually the first, the core part is to be kept, the degree of delight or annoyance of a user of an application or service with the reference to Qualinet. And then there was a note, there's still a note recognizing ongoing research on this topic. This is a working definition which is expected to evolve for some time. This note is not part of the definition. And the proposal is now just to replace this by quality of experience is expressed through appreciation, capturing functions of influence factors with explicit reference to purpose and context of their use. This is what Alex and I proposed, just in order to make clear that there are different views on QoEs possible. But one has also to tell what for. Why are they used, and what is the purpose of them? And I think we have the perfect example of this in the 5G KPI paper, also just on the section 4, because there we have a couple of concrete versions of QoE. Yes, Verana?
Yeah, thank you. This is actually the first time I'm seeing this, so it's really interesting to look at. I was wondering if you could explain a little bit more what you mean by is expressed through. So is it expressed by the user, or is it expressed by the entity actually performing some measurements?
This is at this point still open, because it depends, of course, then on the context on the purpose. Yeah, I mean also it's more like
so my
Yes.
Sorry, then my second question would have been, why would it be the capture of influence factors only and not actually the user's opinion or a measure of their QoE that is being captured? Maybe I'm misunderstanding the definition here.
Yeah, but this appreciation capturing. Maybe this is a weird formulation, but in the end, it's about the user appreciation. We try to find a notion that is a bit more inclusive than perception, satisfaction, acceptance, and so on. Also something that is a bit more, that really reflects back to this degree of delight in particular. Yeah. And
I think
we are maybe. Yeah,
my misunderstanding comes from, we appear to have some delay, I'm sorry. My misunderstanding apparently stems from my interpretation being that it is only the influence factors which are being captured here, rather than the actual measure of degree of delight or annoyance.
The experience factors. We should focus on experience factors more directly. In the original, when we say the degree of delight or annoyance, it's actually trying to explain what quality of experience is. It's almost like we have quality of experience as a term, and now in the definition, we're trying to explain what that is, the degree of delight or annoyance of the user. And then
Also
when we are clarifying and saying appreciation capturing functions of influence factors, it's almost, to me, seems like the same thing. We're actually trying to explain what the words quality of experience mean, like a deeper explanation. So I think we don't want to go, we don't want to depart into
Yes, I know.
more
I
wording
understand
and definition.
the
You know what I mean?
difference.
Yes.
Sorry, could I ask people that are speaking to turn on camera if possible, because this will a little bit increase the chances that we are not talking at the same time. Thank you.
But you can speak. So
Yeah, maybe. Okay, so I will try to summarize. Maybe I think it would be helpful to understand or to clarify this note to say by whom it is expressed, because otherwise it maybe can be misunderstood. And I think there's a second component to how quality of experience as a term is being used or misused in the industry, because when we defined it, or when the community defined it originally, it was meant to capture almost everything as a catch-all term. But in practice, it's always a measure of quality of experience and not actually the user's quality of experience. And by performing a measure of the quality of experience, whether that's subjectively or through some algorithm, there are always some constraints. And this is a frequent source of confusion when talking with the industry. Yeah, well, we're measuring QE, and then we say, yeah, but it's not actually QE that you're measuring. But if at least the constraints were somehow captured, the fact that you are just performing a measurement of QE is what the operational aspect is, which is really not captured here, right?
I don't know, Karan.
Just a point about the appreciation capturing functions. If we were to rephrase these words, what would that be if we were to simply simplify them? To me, functions can be a bit confusing, honestly. So I was just thinking, if we were to rephrase it, use some other wording, what could that be? If we can have a little bit of discussion around this, please. Thank you.
Yeah, Alex, please.
Yeah, I'm actually wondering, maybe we should be replacing this note, right, completely, and rather express what has just been mentioned, that there are different my God, that's a very complicated term, operationalizations of this term, right, in the actual application, which will be specified in the following or something like this, right? I still think it is good that we keep the original definition, but then I fully agree. I mean, what we actually will need is what comes later in your document, and I like the way you have actually put it there, Pablo, based on the input. Is this user-reported QE, right? And the model-based, I don't see it right now, but it's from the white paper, so I hope I more or less well cited it. But I think these are actually the modifiers that are needed to then operationalize it, right? And the question is, what of that do we, if we need a node, I mean, what of that do we already need here, or will the additional definitions, which will be hopefully then in the same part of the document, be sufficient to operationalize the more vague and general QE definition? And then those would actually be the things that are really hopefully be taken up by the industry, because I really think it's actually also very important to know if somebody speaks of QE, what is the person talking about? Is it something that a model has derived? Is it, is it something that a subject test has actually brought up, and so on, right? And that is delivered with these additional terms, not with the base definition.
Yep. If I can hook up here, so this is actually exactly the purpose and context of their use. Maybe we should even talk about the source, where they come from. And this appreciation of capturing functions, this is probably too complex. That we can find find another term if we need it at all, because it's. I mean, the point why this appreciation came on the table is that it has to do something with what the user is thinking or feeling, or it's a view of the user. And of course, degree of delight or annoyance is still abstract. Can we make this a bit more concrete? That was the point. Then the functions of influence factors. I mean, this is of course where the modeling people come into play. It's quite often that it runs out this way, but this is of course not necessarily a pure function, even if you have it in the modeling. But if you have an observation, it's not a function at all. You first have to find that function. But something that I would really like to keep is this purpose and context. Because it's, I think, one of the problems that I've seen with QEE, as I mentioned before, is that people, they're using the same notion, but it can have so many different meanings. So it has so many different applications. So the same way as you cannot, I mean, you heard things like this router can do quality of service 20 years ago. Yeah, similar problem. Yeah, you could not actually point the finger exactly. They did not exactly point the finger at what it was. We have to become a bit more consistent with this. And again, these examples that are below in section 4 here, they are perfect examples how such a contextualization, how such a purpose declaration actually looks like. So therefore, these things, they fit together. And that's also a reason why I would like to see them in the same document and not in two separate ones that we bring into ITU.
Can I? Yeah, so I see two threads with the changing the definition itself. So first one, we just published white paper, and with that we will make it outdated 3 months later. So that's quite problematic. Second one, I'm afraid about lack of continuity between new studies and old studies after the changing of definition, or no one will actually pay attention to this definition. Yeah, so I see these threads with change of it, and how I see it is that with this high-level abstract definition of delight and annoyance, we are describing the discipline, domain, or area of study. Yeah, so it's very broad, and then we can ask, okay, but which QE? And for that, like this whole idea for having layers in white paper was exactly for that. So you have like abstract QE, and then you can ask which QE exactly. And then you have the table from and the definitions from white paper, yes, to have something operationalized. Do you work with metrics? Is it about metrics or is it about measurements? So that was the idea with the white paper, yeah?
So what do we do? I mean, yeah, who's Francois? Yes, please.
I just wanted to add that I do like this note. I think the note is definitely aligned with many research, and I do believe the context of how the customers are using a service, whether they're using it on a mobile device or at home on a computer, the expectations and the context definitely plays a role. And I think Marcus, I remember we did a research maybe 20 years ago, and I think to prove that, but I do like that note. Basically, I just wanted to say that. I agree with the note.
In last research I was searching, I think QoA is a little bit weak about underwater images. For example, no image, generally more videos or more user experiences. I think we should extend like visual content experiences, something like that. It should be more generalized. It doesn't cover images, and also there is no user tasks. For example, there is no response time. If I want to do something about response time, I don't have any definition or any guidelines about it. It is too weak for user side and image side. Just my comment about it. Also for definition side, it should be about visual, generalized, some place should change, I think.
So we are really trying to describe something that fulfills the user's expectation, right? And we're somewhere on a scale from 0 to 100 or whatever it is. That delight or annoyance is really that. If we're talking about images and want to include it, make this more inclusive, it is content then, application, service, and content. Is there a word that encompasses all three? Is there something else? But there's always content in it, right? So it's a consumer of a content.
We have not brought up the content explicitly here because it's somehow overarching as well. But I mean, it could be also seen as included in the context. But of course, we could add content here. But I would like to come back to this part with the user expectations. This is actually part of the QualiNet white paper definition, and it unfortunately has not made it into even not as a note, which would have been actually an option. It has not made it into the ITU definition. So that should be kept in mind. And I think thinking about this proposal here expressed by the user, that is of course, maybe we should say by the user, by or on behalf of the user. Because we have these QoE models, they are actually mentioned farther down. We have to cover this as well. And that is one of the challenges.
About objective. It's really objective versus subjective.
Sorry?
Objective versus subjective. Expressed by the user, stated by the user is a subjective aspect. But we could do the objective one, which is an estimate through a QoE model.
Yeah, exactly. And that is actually mentioned in section 4. Also it's one of these new additional definitions. So I think one of the challenges that we have here is we have to provide an umbrella that is wide enough to cover all the different parts that could come up, but at the same time not trade our basic insights that we have been fighting for such a long time. Because what they presented as an alternative was, what was it? Quality of experience is the experience of a service or something like this. So you explain experience with experience didn't help at all. Yeah, so that is exactly the point. How can we describe this experience part? And that was also the reason why we brought in this appreciation-based capturing functions, because it's somehow linked then to the user, what the user thinks about things. Yeah. But of course, more than open to better wording here. Absolutely.
Okay, I'm just noting down some of the things, and then, but Alex, please go on, and then we can kind of decide.
Yeah, thank you. So first, Camille, I think you shouldn't be worried because I mean, if I understood you correctly, I think the definition per se, we would now decide to actually not modify it, but rather it's the node that would be added or so, right? So it would stay consistent with what it was before, I guess, right? And yep. I think I completely second that. So second point, I mean, I just reopened the QualiNet definition. Why not actually use the two sentences which come, or the one sentence which comes afterwards as another node, right? Which is actually states it results from the fulfillment of his or her expectations with respect to the utility and or enjoyment of the application or service in the light of the user's personality and current state, right? What I liked about the initial comment, I think Emir was the one saying it, is that the expectation would then be reflected, right? Because I really think that that is important, that it is somehow mentioned, right? It's the internal reference which play a role. So why not actually use that sentence and suggest it as another node, so to speak, right? And I'm even thinking, why not actually drop the node, Marcus, that we have come up with, right? Because it was actually written under somewhat slightly different mindset, right, at the time. And instead really, have that as a node, and then have the two specific ones which are in your section 4 there, right? It's proposal number 2, Pablo, in your document, which are these new terms from the white paper. And then we are also not at all in any way modifying the ideas of the white paper, right? Because I mean, the white paper anyways also assumes that the original definition of QE actually holds, as was said also in your document. And then what I think I would suggest to add here for the user reported, right? It can be a node or whatsoever. I think it would be nice to somehow retain the fact, which is unfortunately not in the white paper, I think, but maybe it is, I'm not sure, that this is actually what is very often in the literature referred to as subjective QE, right? And then the modeled QE, right, is basically what we very often refer to as objective quality, right? And then we kind of have also bridged this with the terms, I think it was in one of the online comments, we will have bridged this also to those terms which are really extremely widely used in the literature, right? And then we have actually easily solved that also.
Okay, so okay, yeah, I have. Oh, Femi, please, sorry. You're in the back of the room. It's muted, I think.
Sorry. It was just to follow up on some of the comments made. I was thinking, if we keep the current Qualinet definition, can we then have like a living document, which this refers to, where those extra things can be added to at different points as they come up?
I don't think that ITU wants to have living documents in our recommendation.
No.
Okay.
Okay.
Of course, one can have a reiteration after a while, yeah, and bring it up again. But it's a long-term process.
Okay. More comments on that? I'll try to progress a bit. But there's Francois and Werner who have their hand. And Marcus.
Just one. So, okay, I think go first, Werner.
Okay, thank you. Yeah, I mean, not much of what I've wanted to say has been said already. I think it's really important to capture the expectation part, because we've seen in previous modeling activities that the usefulness of those models in practice also depends a bit on whether users' expectations can be captured and operationalized in the use of a model, and if not, there's no use to even apply some of the models. So by giving this more presence, I think we would capture this effect, which is really also something that happens in practice, even more so as technologies evolve. So this must be there, I think. And I also agree that this note can be dropped because it's probably more confusing than the existing two sentences, and that would give it way more weight if we can just reuse what was already there to begin with, which I also believe captures, it's a catch-all term that captures any type of content and application or service. So I would hope that different types of media are already represented there. There's no need to extend this definition.
Yeah, sorry, I'm opening the white paper because we have the Qualinet definition here, so I can probably copy it. And then we discuss over something specific. So give me a second. It should be here. So this is the sentence that we are talking about. So
yeah.
I will copy it here. Since it's a note, it should be like this.
Exactly. So
this could be an option that we simply add the rest of the definition as a note. So right now, I see we have kind of 3 or 4 options. One is drop all the notes completely. Of course, we can, or we try to rewrite this, or probably follow up.
I will come back